All right, we should be live. Hey, everyone. Welcome to React Denver, March 15th, 2022. We're so happy to see you all. This may be our last time fully remote, but we will, I promise. Live. Hey, everyone. Welcome to React Denver, March 15th. I can hear myself because it's playing in the background.
Nice.
I haven't had that before. All right, yeah, so we're good. But we'll keep live streaming in future months. So Daniel's in Chicago, right?
Yeah.
So we were really happy to be able to connect with people around the world, across the country and everywhere else. I hope everyone's doing well. It's been a crazy couple of years. I think this is 2 years now that we've been fully remote. We started March 2020. Wow, it feels like ages ago, right? But I want to give a quick shout out to Daniel Phillips, our speaker, for joining us from Chicago to give a great talk on WebAssembly for React developers. I've seen talks on WebAssembly. It's actually been a while since I've seen WebAssembly, but I've not seen one for React developers. So I'm personally very excited to hear about how WebAssembly can fit into what I'm doing. I've had ideas and I'm like, I wonder if they're possible. Daniel's here to help us get our bearings with that. And I think this will be fantastic. Big shout out to our sponsor for the last 2 years, Zoom. They have really supported us with sponsoring our meetup before we had to go remote, and definitely supporting us through the pandemic and setting us up with a great account and making sure we have what we need. We also want to thank all of you for staying engaged with the community, for joining us in the last 2 years. Some of you, I'm sure this is your first meetup, and we're really happy to have you here. I hope to see you again for other talks and other topics. And I also want to, before I forget, give you a big invitation to, if you have any interest in speaking at the meetup, I'm going to throw a comment into our meetup page to sign up to talk. We have a few signups from past months that we're going to be getting to in the next couple months. And basically, it's a form you fill out. Say, hey, I've got an idea for a talk. It might just be a 5-minute thing, or it might be a 20-minute thing. You can fill in those details. Share what ideas you have. It does not have to be like a polished proposal like you would to a conference. And we love to start that conversation and support you, whether it's your first talk or you've given talks before. We're very proud that a lot of people have given their first talk at React Denver and have done it again. That's the best positive type of contribution, when somebody wants to come back and they're happy and excited to do it here and to do it elsewhere. That's what I think we are really proud of in our community. We have a lot of great people in it that are doing a lot beyond just our community. And we're really excited to have a guest today. I'm going to say Daniel again from Chicago joining us. He's no stranger, of course, to Colorado. You attended Turing, right?
Yeah, like ages ago, 20.
yeah, he's from
2017, 16.
Awesome. Yeah. Attended Turing School in Denver and works with a company out of Boulder. So super happy to have him as our guest speaker today. With that, I want to turn it over to Daniel. We'll jump right into it.
Cool. Thanks a lot, Will. Yeah, so can everyone hear me? Let me just get a thumbs up. Just cool, because sometimes people are, all right, great. Thanks so much. Yeah, okay, so I'm going to talk about WebAssembly today, and it's going to be for React developers. And before we get into it, I kind of just want to highlight the sort of goals of the talk. Basically, what it is, why it's important, why I think it's important, how to use it briefly, although there's a lot to that, but we will talk about it. And then what I think you should watch for as you start to hear more about it. And also why now is a particularly good time, I think, to start paying a little bit more attention if you haven't. So let's see, go. Yeah, so like Will said, I did live in Colorado for about 7 years. I was a student at Turing back in 2017. And prior to that, I have a background in linguistics and computational linguistics. And currently I'm a platform software engineer at a company that's based in Canada. But we had an office in Boulder, so I used to work there, and I lived in Broomfield for most of the time that I lived in Colorado, Denver for a bit, also Boulder for a bit. I've been a huge stan for WebAssembly since I started getting into it in 2018. And I'll kind of talk about how it sort of became more clear to me that this was something that I thought would be cool, and why hopefully that can translate into other people thinking it's cool throughout this talk. I also recently started the WebAssembly Chicago meetup group, which, as it stands right now, is one of the more active WebAssembly focused meetup groups in the country, or even in like the whole continent, really. And we work with the guys at WebAssembly San Francisco, who help us to sort of promote events, put on events, source speakers, things like that. And we just had our first meeting last month, and I was just talking to Will about that. And yeah, we've got more stuff coming down the pipe. So if you're interested in this after this talk, feel free to hit me up and I'll give you some more resources in that regard. Like I said, I used to live in Denver, and I remember fondly the basement meetups with pizza and beer and actual people to talk to, which was pretty fun. And I'm looking forward to that again at some point soon. And some React experience. I do have some React experience in a production environment. I've worked as a full stack dev. I've done work with Ruby, Python, Ruby on Rails, Django, Fast API, backend stuff. Now, the most recent front end stuff that I've done is a lot of Vue.js work, which has some sort of crossover into as far as concepts with React, from what I can understand. But my React experience was back in actually pre-Turing for a second. So like back in 2016, and then also in 2018, which was like, before hooks were even a thing, as far as I can tell. So yeah, it's been a minute, but I have some experience with the framework. So I'd like to talk about, well, it wouldn't really be a tech talk unless I showed you one of my own tweets. So I wanted to talk about this thing that I tweeted the other day. And this was the day of our first Wasm Chicago meetup. And I tweeted this tweet, which lists a bunch of areas of tech, of software development. And I said that there's a pretty good chance that you will encounter WebAssembly if you work in any of these fields at some point in the near future. And what I'd like to do throughout this talk, really my goal for this talk, is to work on convincing you that this is not just hype, that this tweet is not just hype, and that this is that, like, I was actually being serious. And maybe we can move things along, and I can kind of bring us to a point where you actually believe me. Cool. Oh, and I was going to say, let me see. Yeah, okay, cool. I was going to say, if you have questions, feel free to drop it in the chat. I'll keep the chat open. And also, I don't know if there's like a hand raising thing, but if you want to ask a quick question, feel free to stop me and raise your hand or whatever. Cool. Okay, so I'm just going to start off with the basics, and then we'll kind of move through things. So what is WebAssembly, or Wasm? Wasm. It really doesn't matter. People in the field say it both ways. Technically, it was sort of the successor to what was ASM.js, ASM.js, right? So if you wanted to use that as a pronunciation guide, maybe it's Wasm. Technically, it doesn't matter. WebAssembly is a safe, portable, low-level code format, which is really designed for efficient execution and compact representation. It's safe, sandboxed execution and environment. It is a deny by default, which we'll get into how this works and why that's the case. And it makes no assumption about languages or hosts that are being run on it or compiled to it, okay? So without getting into the weeds, basically, you can think of it as a virtual CPU, right? So it's an instruction set architecture that sits just on top of your computer's CPU, right? It's a binary format, right? So it allows bytecode to run in basically any environment that can run binary, all right? It can be run compiled, or it can be, it can be compiled ahead of time, or it can also be compiled, it can be compiled, just in time with a Wasm runtime, right? We'll get more into this as we kind of move forward. Cool. So a lot of people come to talks like this from the JavaScript world because they want to know how it's about its relationship with JavaScript, right? So just to get this out of the way, Wasm is not going to replace client-side JavaScript anytime soon. And there's a couple real reasons for that. couple of years ago, Dan Abramov had this piece that was called React as a UI runtime. Dan was, maybe is still actually, on the Facebook team that I think manages React. And I think he made Create React App library. I'm not quite sure. But anyway, it's a really, really great piece if you're interested in sort of like philosophical approaches to building UIs, right? And the thing with WebAssembly is that it is like the farthest thing from that. Oh, he made Redux. Got it. Cool. Oh, Redux. Yeah, cool. Nice. Yeah, WebAssembly is like the farthest thing from a UI runtime. If anything, it is a compute runtime. Okay, that kind of is made to work in tandem with a UI. In fact, what I'm going to try to show you in this talk is that Wasm right now will make your UI runtime worse in many cases, right? If you try to leverage WebAssembly for things that interact with your user interface a lot, it is not really, it doesn't really shine in that way at this moment. So we'll get into that though. The other TLDR thing is that more and more things are going to be built and ported to WebAssembly. And we'll talk about this and we'll talk about some examples, but more things are happening every week in really creative and interesting ways, right? Like I said about UI runtime, we'll talk about this too. Interop with JavaScript. So going from WebAssembly to JavaScript is getting better and has already gotten better in the last 7 years, right? When WebAssembly was first released, it was released as an MVP. JavaScript has been able to be tuned for the last 30 plus years, right? Even though it was, written in 5 minutes or whatever by Brendan Eich, it's still like they've been working on the runtime for JavaScript for quite a while. So like I said, now is really a great time to get started watching because like Will said, he said that he's been to some of these talks. Oh, I see. Yeah. Okay. Yeah. Like we've probably heard about Wasm for a few years now, and a lot of people are kind of wondering like, why is it taking so long? And it's taking so long because it's kind of a unique beast in certain ways. It's really unique in terms of who's involved. Right now, all of the major browsers and people who work on the browsers themselves are involved in the sort of spec and stewardship of the progress of Wasm. Okay. It's kind of an interesting thing, right? When JavaScript was being written in sort of like a hasty manner, if you ever go back and read about the browser wars of the 90s, it was really like whoever got it done first won, right? And so like when you had Brendan Eich, who was trying to, I think, it was at the company Netscape, that they were trying to like get some sort of runtime language for a UI, right? So a really cool post, which is on Brendan's own blog, is talking about from Asm.js to WebAssembly. And I'll link these slides and I'll also drop it in the chat too once we're done here. Cool. So, sorry, thought somebody was at my door. Problems with presenting from home. Cool. Okay, so what is the point? The point of WebAssembly is a universal compilation target for a polyglot feature that's safe, fast, and portable. And that's the cool thing. When we say universal compilation target, when we think about it's actually interesting because when people who don't work in front end client-side JavaScript stuff, they may not think of the web as being a compilation target. But I think people in the React space and in like the Vue space and in the SPA space do think of the fact that like when you're writing JavaScript these days, modern JavaScript, you are compiling it so that it can run in a specific environment that is best for the user, right? So with some of these things, this is kind of where we'll talk about where WebAssembly shines. The basic rule is that computation heavy things that are not highly IO bound is really still where Wasm in the browser does extremely well. Okay, so I'm just going to walk through a couple examples, and I have IO bound in quotes here because I don't mean like file IO. I mean like in and out of the actual Wasm box itself, right? Like what is being run by WebAssembly, if it has to leave and come back from that area, it's going to suffer in performance, and it's really not going to have any benefit to your app or to whatever its intended use is. So talk about a couple cool examples. Yeah. Oh, thanks, Will, for dropping that link. The first one is from last year, which is a pretty cool demo. I'm not sure if anybody saw this. It's from a company called StackBlitz, right? StackBlitz does web-based IDEs. Oh, sweet. Yeah. So this demo actually blew my world. I mean, this was wild. So what these guys did is kind of in secret, because this is not open source, unfortunately, but they have said that they're going to open source parts of it. For 2 years, they worked on building a Node.js runtime that can run inside WebAssembly inside your browser, right? And they called it a web container, right? So they had to build a virtualized TCP IP stack, right? They had to build all the networking. They had to make shims for all of the system calls, right? So like anytime you're in Node and you want to access the file system, they had to figure out ways that wouldn't just cause problems. And then they built that into this. I'm not gonna spin it up right now because it does take a second, and I'm already doing Zoom. But I highly recommend checking this out because basically you can get some code from GitHub. You can clone it down into this browser environment. Then you can bundle it. You can npm install it, right? And then you can spin it up and serve it right there from the browser, right? Which is pretty cool. I was kind of blown away by this. I think it was last May or something. Another one is this guy Colin Everhart, who is actually, if you're interested in like WebAssembly news, he puts out this really cool newsletter called Wasm Weekly, with like new stuff that's happening in the Wasm space each week. And so a couple of years ago, he did this thing, and here's a demo of it right here, right? Where it takes a C++ computer vision library, it takes TensorFlow, which is a machine learning library, and then a Sudoku solver that he wrote in Rust, right? And then he lets you use your camera in a browser, solving a Sudoku puzzle on the fly just by holding it up like that, right? And this all happens client side, right? So going back to what we talked about with a compilation target, right? This is an example where you use C++, and we'll get into the tooling about with this that he used, but C++ using this tool chain called mscripten, which allows you to like take those libraries, compile them to Wasm, figure out the interface, which is where it gets kind of challenging, right? And then do this kind of stuff in the browser. Jupyter Notebooks, right? If anyone's done machine learning stuff, this was a project also extremely cool. I've done some data modeling and machine learning stuff for work, and there's a lot of dependencies with pip, right, with Python. And this takes actually a specially made Python runtime, the entire Python interpreter, wraps it up in a WebAssembly module, and then ships it to the browser. And then you can run a Jupyter Notebook in your browser, do machine learning in the browser with a pretty big footprint, honestly. I think that the size of it all is like it's like 5 or 10 megabytes or something that you have to ship to your browser to use this. But it's more of like a proof of concept than anything at this point. Some people might have heard of this, TensorFlow.js. Okay, TensorFlow is a really popular machine learning framework. This one has sort of systems level postscripts that install that need to do a lot of calculations, like a lot of CPU heavy stuff, really fast, right? And I wanted to show you this interesting benchmark, maybe somewhere. Yeah. Okay, so actually kind of similar to what Colin did. I'm not sure if he used this exact library from TensorFlow. But basically, TensorFlow is a JS wrapper around a bunch of Wasm modules that are originally C++ libraries. And you can see here that these benchmarks allow certain things to be almost 20 times faster than just using JavaScript, right, in certain ways. That is to say, though, I will say that a lot of people come to WebAssembly and they think it's just going to make everything fast. Like, it's just like you're going to do something, and if you use Wasm, it's just going to be a silver bullet. It's actually not the case. And in many cases, if you do certain things with very carefully in JavaScript, in like the V8 runtime, for instance, JavaScript will be faster than many things. I mean, they've been working on optimizing JavaScript's JIT for like 30 years, like I said. So JavaScript for an interpreted language has gotten really, really fast, right? So it's not just like an across the board silver bullet. And I think that a lot of people get really excited about the prospect of using Wasm. And then when they get into the weeds on it, they're kind of let down that it's like not really something that you can just like plug in and blast off with. I do think, however, though, it's slowly getting there in some respects, right? And there's a little bit more that I'll show you that that can kind of maybe convince you of that. If we have any crypto people who are into crypto, there's a project called Polkadot that uses EUE Wasm, which if anyone is involved with the Ethereum community, I believe actually Ethereum Denver just happened, right? A couple of weeks ago. Yeah, so like Ethereum runs on its own virtual machine, right? WebAssembly is a low-level virtual machine, which is like a stack-based machine, which is how it basically translates everything into instruction sets, right? I'm not going to get into that because that's much more complicated, but just know that it's a very low-level VM, basically. And so there's this idea that you can take the Ethereum virtual machine and swap it with eWasm, which is a Wasm-based virtual machine, and then you can have distributed computing across multiple different hosts. I didn't really touch on it super specifically, but in the definition of Wasm, I think I mentioned that Wasm makes no assumptions about the host, right? So they designed it thinking about like WebAssembly is not going to know if it's in a browser, if it's on a machine, if it's on a phone, if it's in a VM, if it's in a container, right? So one of these ideas is that with actual portability to your Wasm module, it's all kind of the same. And if you want to give it more capabilities, you have to bring that in yourself, right? So there's many, many more cool examples. There's this fun website that's called madewithwebassembly.com. And it kind of it's relatively recent. I'm not sure if they're still updating it, but it's got some really cool projects that people have taken from these more systems level languages and ported to WebAssembly. I definitely recommend checking it out. Cool. Cool. Any questions right now before I keep going? Because we're going to get into the sort of implementation now. Yeah. No? Okay, cool. All right. Yeah, so how do you use it, right? I think this is also a place where a lot of people are like, oh, there's this cool thing that's in the browser and it's been around for like 5 or 7 years now. How can I actually do it? Well, the thing is like there are JS developers, right? But there aren't really like Wasm developers because you're not writing Wasm by hand. Like you can, but like it's not a good idea. There aren't Wasm developers, just like there aren't container developers and there aren't binary developers. I mean, like there are, but it's not like most people who are writing business logic, right? So to kind of illustrate that point, when you use Wasm, or if you've looked at any sort of web page that loads a Wasm module, what you will see is WAT, right? So this is my little play on words here, but WAT is a WebAssembly text format, right? Which is basically a textual representation of the underlying binary format. So when you look at this, let me show you what this looks like. Right. We go to our source here. We'll talk about this here. But this is WAT right here. All right. if anybody's ever done any like Lisp programming, this is based off of S expressions. And basically what it allows you to do is sort of show you how different things are working in the stack machine. It gets very, very involved. You can write this and it can execute Wasm, but this is for such a simple example. It's best not to do it this way, right? Maybe if you have to debug something that there's literally no other way, this is how you do it, right? It's kind of like if you have to debug like binary and read hexadecimal, like it can be done, but like not really recommended. So a better place to start. So this is what you see when you see it in the browser. A better place to start, especially for JS developers, is assembly scripts. Has anyone heard of assembly scripts at all? No. Okay, cool. Yeah. See, unfortunately, the marketing team does not have a very big budget with WebAssembly, right? It's kind of a joke. But you probably heard of Rust, right? Yeah, so people have heard of Rust. But the irony here is that assembly script was made for JavaScript developers and is actually like maintained for people to have sort of an easier time moving from, say, TypeScript to assembly script, or to which assembly script compiles to Wasm. I'll show you this without getting into the details too much. If anyone has experience with TypeScript, which I think like there was a talk here recently about TypeScript, I like jumped in on it for a second. Yeah, I mean, TypeScript is awesome. I think it's cool, and TypeScript compiles to JavaScript. So assembly script has a very similar syntax. Obviously, there's different underlying details, but you can see here, like this looks kind of familiar maybe, right? So this is a JavaScript-like syntax, which does a Mandelbrot set, which is like a kind of a classic math illustration. And I'll show you what that looks like as WAT, which is, this is the WAT file, the WebAssembly text file, which is the representation of the underlying binary, right? And you can see, like, you could read this, but this is like one of those blocks, right? It's like, it can be done and you can learn how to do it. If you're really, really, really bored, like feel free, you know, it's kind of cool if you're interested in like learning how the actual stack machine works, but that's like for if you're really, really curious. But let's run this. Cool. So this uses Canvas to run the compiled WebAssembly code from that assembly scripts code that we saw here. So basically like source code, kind of like object code, result, right? This does use Canvas. I'm not going to touch on Canvas too much. Like people have heard of like WebGL and Canvas and stuff, and there's kind of this association with Wasm with those technologies because you can kind of sidestep certain DOM interactions that way. You can and can't. It is a way that people do pixel-based rendering of stuff for sure, and I'll show you some examples of that later on. But yeah, so this uses Canvas Mandelbrot set with assembly script. So I definitely recommend checking out assembly script if you're interested in like writing something that's JavaScript-like that can do something with WebAssembly. Okay. To back up though, I will say that performance-wise, this will not give you a ton of like in most cases, it will be difficult to find a huge performance increase in doing this way. All right. And I'll get back to that again. And then Rust. So we've heard of Rust. There's a lot of hype about Rust right now, especially in sort of like the Node JavaScript client, like ECMAScript, Node. There's Nappy RS, if anyone's heard of that. It's like the guy who there you can use Nappy to write stuff in Rust that are extensions for Node libraries with npm, and like the company Vercel, the company that's been like just buying up all these people that start like open source projects. He just joined Vercel to work on that full time there. And Rust is awesome. Rust is really cool, but like Rust started as a systems level language to sort of like be a replacement for things like C and C++, because like those languages they have really steep learning curves, but so does Rust. I'm also not a Rust expert. So I know about Rust in the context of WebAssembly, and that is mostly this library right here, which is called Wasm bindgen, right? And if you're curious and you want to like add some of these buzzwords to your resume, make some stuff with Rust and Wasm bindgen for sure. All right. So like there's no like this is people are like rusty JavaScript and stuff. Like this is what they'll do with that, right? Um, there's like a lot to unpack here, which like this right here could be its own talk, like or a series of talks actually. But basically, the story with Rust and WebAssembly is they both came out of Mozilla, kind of more or less over the last several years. So there's like a close relationship, and Rust has a very great tool chain for WebAssembly. And then this library is also really great for doing interop between JavaScript and WebAssembly, which, like I said, is a very delicate thing that can actually make things harder. Like it's very hard right now because everything is so new. Okay. But Rust comes along with this library. I don't actually know the story about this library. I think Steve Klabnik, who worked on Rust, was involved with this, but I'm not totally sure. I'm not an expert here about this particular thing. And basically, what it does do is it there's performance costs to leaving WebAssembly, going to JavaScript, and especially going to JavaScript to do something on the DOM, or to like do something on like the abstract syntax tree, which governs the virtual DOM, right? So there's like many steps to get to your React code from here. But I will say that Wasm bindgen does a good job of smoothing over some of these things and trying to like make sure that they work nicely together. Like for example, like something as simple as like strings, going like taking a single string of like say 10 characters from JavaScript to WebAssembly is not a trivial thing, right? Rust and Wasm bindgen, among other, there are other libraries for this too, but this is kind of like the forerunner that kind of like smooths that out and has optimized it. And that's the kind of optimization that can help with certain things, right? And this is actually going back to that StackBlitz example. They kind of use this, from what I understand, they use Rust to sort of work on some of these things like mocking out system calls and shims to be able to like, and then if they had to do DOM stuff, I think it was written with this library. Basically, anything UI based with WebAssembly, this will get you there faster. But Rust also has things about it that you have to learn that are very, very different from JavaScript, but also cool, also like pretty fun. If you get into Rust, like I have spent most of my career using Python and Ruby. Like I did Python before I attended Turing, and then I did Ruby, and like these languages like are very, very different. I've done some C and C++ in very like specific things, but like it's just a totally different world. And Rust is a cool intro to that, in my opinion, from my own experience. So that's kind of like good places to start. If you're looking for a place to start, look at these three things, right? Understand what WAD is, okay? Check out assembly scripts. The MDN docs have tons of assembly script stuff. It's really, really cool. And then Rust, Wasm bindgen for sure. Cool. Any questions about that? No? Okay, cool. So yeah, it wouldn't be a meetup unless we talked about best practices also. So I put best in quotes because like this field is so, this space is so new and changing. Like what is best could rapidly change depending on how the implementation changes. The implementation is taking a long time, like I said, because they're really basically trying to get it right, right? Everyone has an incentive that we can all have a cross-platform environment to run whatever programming language that we want. And that's a huge task, right? And some of the features that have come down the pipe, like they've really debated them. Like the last one that just moved from stage 1 to stage 2 of the proposal took like a year. And I'll touch on that if we have time. But yeah, so best practices, here's what I would do if I had something that I wanted to do in Wasm and then tie it to some front-end project that I already have. So general rule is load it asynchronously, streaming. This is the same code snippet. But basically like here, like this is, if you're a JavaScript developer, this is pretty straightforward, right? Like these things get loaded together. The kind of interesting thing is that over the wire and then into the browser, the WebAssembly code, because it's binary, actually gets parsed and loaded like several orders of magnitude faster than your JavaScript code, which is kind of wild. And there's some really interesting benefits there. So that's why like you have to do it asynchronously, because they kind of have two different loading mechanisms. But basically, this is a good place to start. You don't have to stream it all. You can send it all at once. Size does become a problem with Wasm modules. It's being actively worked on. But basically, you can also do module linking, static linking. You can do things where you try to use HTTP multiplexing to bring them all in at the same time over HTTP2. Like there's a lot you can do to deal with like the size limitations, but that's also kind of beyond the scope of this talk. So basically, it's as simple as this to get started with a Wasm module that you already have, right? But like the thing is like, where do you already have that from, right? I kind of talked about that for a second. Yeah. So where do you get your Wasm module from? Well, a good place to start, like this is where I started, because I was like, okay, well, like, how do I do stuff with this? Is like, find a tool or an example of this, of a tool that is like maybe not written in JavaScript, but written in a different language that you know or like or have heard of, and then see what exists for it to be ported to this environment. One of the coolest examples that actually kind of that I saw a couple of years ago, which I really liked, which I'll show you here, is this project, which is a port of Vim to WebAssembly, right? Vim is written in C, and it actually has its own scripting language built into it that's also written in C that's called Vim script. And this guy took that and ported it to WebAssembly. You can see it here. So you basically have what is mostly working Vim implementation all in the browser. And so this is like a very, very involved example, but it involved sort of the same thing where it was like, okay, let's take something written in C. We can use these tool chains, which I'll link to sort of like resources about the tools that make this type of stuff possible. And then he had to figure out the interface between the DOM and the Wasm, right? So that's again kind of where things get challenging. But I'll also point to some resources about that. Cool. Yep. Leave you. Yeah. Another one too is there's a background. I'm sorry. There's a sort of Unix library called JQ. If anyone's ever used it, it's like a JSON parser. That is a command line tool, and this person took it and decided to port it to WebAssembly. And this one was probably actually more straightforward, because it's literally like you can port that tool, you pass it a string, and then it outputs this other thing. So figuring out the UI for this is probably a lot easier than something like that Vim example that I showed you. So these are examples where like you have these other tools that maybe you can bring to the browser, right? Really sort of like where things are at now is you've kind of got like, you could theoretically have like multiple teams in your company or in your organization that like you've got like I was talking to my friend who works at Twitter, and like she's on like the fire hose team, or she was but basically it's like they're doing all like Scala and like C++ and stuff, and like they could build a tool and then compile that to Wasm, hand that off to the mobile client team, and they just need to figure out the interface, right? Which is like really where like you can hand it stuff and receive stuff, right? So it's basically like a black box with a window, and this can all be done and shipped in the browser. A cool example of this, which I'm not going to show either because it's a little bit unwieldy, but if anyone's used FFmpeg, this is a cool library for video and picture manipulation, which is very computationally heavy, excuse me, and really, really cool demo. And they even have examples of how you can integrate it in your own client-side app here. Yeah, I'm not going to demo because I did it earlier and it was kind of like, it didn't tell me, I'm not sure about the interface completely, but it does work and it is cool. And I recommend checking this out. And if you look, like, you can look at the repo for this, right? Like the actual library itself is written in C and actually assembly itself. So also this took some work to port to WebAssembly. Cool. Yeah, and like I said, like doing actual work in this regard, like we could turn this into like a series of like workshops to kind of go into this stuff, because there's like a lot that goes into it. But basically a great place to start if you're a JavaScript developer is on this page exactly, right? So this is the JavaScript API for Wasm, MDN docs with their like redesign here, which I've been noticing the last couple of days. Really great examples, and they kind of go over everything that's possible, and then also things that may be a little bit outside of things that we experience as JavaScript developers, like memory management, dynamic linking, things like that. So this right here is a great place to start. Okay, how am I doing on time, Will? We good?
Yeah, you're doing great.
Okay, great. Just wave at me if I'm going too long here. Okay, so now I'm going to do what you're not supposed to do, and that's try to predict the future. And we'll kind of talk about like some things that are like works in progress, and some things that are coming down the pipe that seem to be pretty substantial. So if you remember that we talked about that WebAssembly doesn't make any assumptions about its host environment. This actually turned out to be a very interesting choice, an interesting, choice of the design team. And it's actually one of the things that got me really interested in it after I kind of learned about what it can do on the front end. I was kind of excited about what it can do on the back end, maybe as much or more. If anybody remembers how penicillin was discovered, like if you've heard about this, right? Like it was like an accidental discovery. Okay. And for me, this is kind of like a thing that I'll use to kind of talk about this. If you look at WebAssembly, right, and you think about what it does, it creates like a sandboxed execution environment for code that's secure by default, that you can run an application in, and maybe you could run multiple applications in on the same host, on the same machine, in different WebAssembly boxes. If you squint hard enough, which is what they say, kind of looks like a container, right? It kind of looks like maybe a Docker container, right? Or maybe it kind of looks like a VM. And some companies realized this. Some people realized this. Some really smart people a few years ago. And companies now like Fastly and Cloudflare, they have actually leveraged WebAssembly to power their entire serverless architecture on the back end, right? And also not just on the back end, but what people refer to now as the edge, right? So edge computing. Fastly is like a CDN network that realized they have all these servers all over the world. And then they're like, oh, we've got these servers everywhere and we're just serving static sites. Why don't we try to do stuff with like beyond static sites? So they were like, okay, Cloudflare Workers, or Fastly, I think it's called Fastly Serverless, right? And so basically like you can use the Jamstack thing was really popular a few years ago, and it's still very a popular thing. And the idea here is like, okay, well, what if we took functions that users like that, developers wrote, and then we took that function and we compiled just that function down to like one little tiny WebAssembly module. Well, it turns out that like the way that serverless was done before was maybe with containers or with partitions or something like that. Well, this little tiny WebAssembly module, it turned out that this is why it's a penicillin thing, is because this little piece of code just comes up and disappears just like that. If you've ever tried to boot a container with a runtime in it, like Ruby, Rails, Java, Node, whatever, like it could take a few seconds to boot a container like that, right? But with a Wasm module, it can spin up and down literally several orders of magnitude faster than a container. So that's kind of cool. The other thing that's kind of cool is containers. If people are really crafty, they can get broken out of, and then you're on the host OS. Um, with WebAssembly, you can't go anywhere if you don't know where you are, right? So like to bring a networking stack to WebAssembly, you have to like bring it with you yourself. There's a lot to this, and actually I'm really excited about it. There are a couple companies that are doing some really cool stuff, but like one project that's been around now for a minute you might have heard of is Crustlet, which if anyone here works in Kubernetes or Docker space, Crustlet is a comes from the same people that brought you Helm. And basically Crustlet lets you run WebAssembly workloads managed by Kubernetes. Kind of interesting. And there's a lot of companies that are kind of working on that same path, right? Again, I've said this several times, unfortunately, because this is like how these things go with this space, but that again could be its whole other talk. And we actually have a couple speakers lined up to talk about these very things and other things at the Wasm Chicago meetup. Yeah, and so like one of these things for the back end or for the edge is WASI, which is kind of like the Wasm successor of POSIX, right? So it's like POSIX is the portable operating system interface. WASI is the WebAssembly system interface. So let's say you have some WebAssembly code. It would be cool if there was a standardized way to like access, you know, a socket, or to access a port, or to access a file system, or to access you know, other things that you would find on operating systems or in browsers. And the idea here, this is actually under really active developments, which is pretty exciting. So the same team that's working on the WebAssembly standard is working on the WASI standard. And like the idea would be like, this is what would bring you actual portability that you could just plug in, right? That's pretty exciting. And like I said, if not only are WebAssembly modules of the same code several orders of magnitude faster than containers in certain instances, they're also several orders of magnitude smaller. Okay, right? So like if you ever do stuff with Docker, you could easily have container images if it's like, I don't know, a Ruby runtime with stuff like that could be like I mean giant, right? Like the same code, if it's just going to execute like one serverless function, is much smaller. So WASI's kind of bringing these things there. Suborbital, absolutely. Suborbital is huge. Nick, yes, I was going to mention them. They're awesome. Actually, Connor is the guy who helped me get started with the Wasm Chicago talk. He's the CEO. He works on the WebAssembly SF group too, and they're doing some really cool stuff, right? And a lot of it's open source. So if you're interested, I highly recommend them. Also, they stream a lot too. So like if you're interested in backend WebAssembly stuff, the Suborbital team is really dope. Another one that's actually, I think, associated with some Colorado people is Fermion Tech. It's I've got a link here. They're the Crustlet people, and they're also doing some really interesting stuff in the space. So I'll drop this. I've actually got these slides hosted, so I'll drop that in the chat when it's all over too. Cool. So that's the outside of the browser, which, like I said, is a whole other thing, but super cool. And it's actually like all this stuff together is like I kind of started hearing about over the last few years, and I was like, this is so cool on so many levels. And like when I moved to Chicago to be like, my wife's here, like I was like, all right, well, I would love to just organize people to get into this more, and that's why we started the meetup. But like there's still so much so much space and so much activity just in browser-based WASM. And I shouldn't say just, because it's like a huge transformational thing too. The big one is garbage collection, the GC. Okay, so like languages like Rust, C, C++, you have to manage memory yourself, right? Which can be very tough if that's not something that you're used to as a programmer. JavaScript, Ruby, Python, Node, like these things have garbage collectors. They also have they're dynamically interpreted. They have just-in-time compilations, so they're optimized at runtime, things like this, right? The browser implementation of Wasm just moved forward a garbage collection proposal into the next phase, which is like a public comment phase. This is all on their GitHub too, and you can check out the proposals. You can check out the features and like the specs and stuff. Highly recommend it. They have all open communication about all of these things. You can even open an issue if you're curious, or if you have something that you're if you're not sure about, they'll actually answer. It's super cool, super great group. Garbage collection native to the browser would allow like these projects where you took like the Python Jupyter notebooks, okay? Instead of having to bring all of that with the Python runtime, they could leverage the optimized garbage collector that already exists, so that that Python module wouldn't have to be like 10 megabytes. It could be like maybe like 2 or something. I don't actually know. I've never worked on this, but basically it would be like an optional garbage collecting service that you could use with your with whatever you're porting to Wasm, which is really cool for the systems languages like Go. If anyone's played around with Go, Go is garbage collection, but then there's this like version of Go called TinyGo, which is actually kind of optimized for Wasm itself. It would just kind of make these things a little easier across the board. The next huge one is interface types. Interface types are coming down the pipe, and like I said, garbage collection took like more than a year of debate, which is a good thing if we want all these browsers to get it all right, right? So interface types, I've heard that interface types might take even longer than a year, because interface types might do things like allow you to interact with the DOM without JavaScript. And how to do that, and how to do that in a way that everyone is happy with, is a gigantic thing to tackle. And it's not just the DOM, it's also like other host environments, right? Because like I said, no assumptions about the host. So if you're going to watch for anything with WebAssembly, if you hear about this interface types things, I would definitely perk up and just be like, okay, what's going on with that? Because that could be really, really cool. And if they get it right, it could really mean some really interesting things for the web platform. Some other interesting ones for that I think are pretty cool, but maybe a little bit more like niche, are SIMD, which is a same instruction, multiple data. It's like a processor specific, well, not specific, but it's like a CPU technique where you can like do the same operation at the upper bound of the CPU, like so like you could do, instead of having to do 100 things sequentially, you could do them all at once if it's the same operation. Browsers actually, I believe, the C++ code that optimizes the JIT, the V8 JIT compiler uses SIMD in some ways, and that's actually what makes JavaScript sometimes faster in your browser than it does in Node in certain instances. I'm not an expert there, but I've heard of that. Anyway, SIMD is coming for Wasm. It'll make things like certain things much faster. And then a networking stack, right? So like if you could do if you could do HTTP calls, TCP, UDP over like without having to use JavaScript, but right from Wasm, and even like possibly like inter-process communication, if you've ever played around with that stuff, like Unix stuff. I don't actually know much about the proposal, but I do know a lot of people are very opinionated about the Wasm networking stack's potential. And so that's another big one to look out for. And yeah, so a cool project that lets you check which feature. So unfortunately, like there's a standardization of all these things, but all the browsers have to implement them themselves with their own teams, right? Like they don't do each other's work for each other, right? So sometimes there are slight differences in what browsers have what, but anyway, this is a really cool library that Google came out with that lets you check if certain features that are on the WebAssembly feature list or proposal list, if they're supported. So if you do want to use something in like a more serious project, like check this out. This is like really, really cool. There, you know, some browsers don't quite have the same resources as like Chrome or Firefox or Edge, right? And so, I mean, because browsers are like a huge complex beast, of course. And so this is a good one if you're dealing with people who maybe use Opera or like, you know, whatever. Cool. All right, I'm gonna bring you back to my tweet. I've been talking for a while now, but yeah. So like my goal was to kind of have to kind of make you believe that like a tweet like this is not just hype. And you'll notice that I didn't even touch on a couple of these things, right? I mean, I touched on like, didn't really touch on native development. I didn't really touch on IoT or embedded systems. But the interesting with those is that the stuff that is happening, say, with like IoT and embedded systems is, remember at the very, very beginning, I said that WebAssembly is like a virtualized CPU. Well, if you have a virtualized CPU that can run on any machine, why can't that run on like a Raspberry Pi or an Arduino or some other tiny IoT device that you would normally have to write processor specific code for? Why not just put a layer of Wasm on top of it and run that anywhere with a very small performance change? People say that Wasm is near native, right? It has near native performance. Okay. And like there's a, people, developers like to argue about stuff. So like what does near mean in that sense? And the answer is, like with everything, is that it depends, right? But like in general, with things that, let's say, like you can, if you're doing something that's interpreted, right? Like that's like something like the Ruby interpreter compiles down to C, right? What you might find is like WASM versus something happening on the metal itself. You might find a 5 to 10% performance hit in certain times, but in other times you might find a higher performance hit. But basically, like my point in telling you this is that when they say near native, depending on the runtime on the Wasm implementation itself, it's usually so low of a difference that it doesn't matter. Like it's kind of moot, right? Um, but there's a lot of caveats to that. So it is definitely a good thing to watch, because like a lot of people like to sort of talk about different benchmarks of WebAssembly versus JavaScript versus native code, and really like there's like a lot that goes into that. But just something to be aware of. So last thing here, go back to this Brendan Knight quote. He used to say this thing, he still says it. That's always bet on JavaScript, right? And at the article that I posted earlier, which I'll drop here in the link with the slides, is where he was first introducing Wasm back in 2015. He ends the article with this. He says, always bet on JS. I look forward to working and Wasm into that line. No joke, right? So yeah, maybe I'm not sure exactly where that was, but I'll drop it in here. Yeah, so if you're looking for more interest, more resources, if you're still interested, I'll drop these slides. I'll post them on my Twitter and I'll drop them here. If you're interested in sort of getting involved with stuff, the Wasm Chicago meetup, our next meetup is in early May. We're going to be announcing the details of that soon. A really great book that I've just been finishing now is WebAssembly, the Definitive Guide. This book here, right? It's by this guy, Brian Sletton. Actually, we were lucky enough. He came and spoke at our first talk. Like we were super lucky. I mean, I just like cold contacted him on Twitter, and he was like, "Yeah, sure." And I didn't realize how great it. I mean, it was just like it was incredible. So like I highly recommend that talk. Like we really got super lucky with him coming to speak. It was a great way to kick off our first meetup. And he presents things in a very accessible way. Fermyon language tracker. Like I said, I'm pretty interested in where things are going with server-side Wasm. But this is a good job of kind of like showing you like where support for WebAssembly exists currently with different ecosystems, right? And you can even click on these, like click on Ruby, and it like they do a really good job of like talking about all the different open source projects. Artichoke is really cool. It's like a Ruby that's written in Rust. Ruby, actually, the creator of Ruby just approved a pull request that has native support for compiling certain things to Wasm in C Ruby. Yeah, I mean, so like this is a really great place if you're interested in that sort of like side of it. And then yeah, for sure. This is a really cool GitHub repo. Great place to start. Awesome Wasm. which then kind of throws into question like the whole pronunciation thing. It doesn't matter. Like Wasm, Wasm. It rhymes better that way. But anyway, really, really cool list of tooling, of examples, of runtimes, lots and lots of stuff. This is a great place to get lost in. Talks, some really great articles and talks. Really, really cool. So yeah, thanks. I wanted to say a huge thanks to the organizers, Will, Jeff, Sam, David, Diana, and Kevin. Yeah, I mean, I just started organizing this Chicago meetup, and I think like a lot of people, I underestimated the amount of work that was involved with it. And we haven't even done an in-person meetup yet. And it's still been a lot. So like none of this would happen without these people. So big thanks to them. If you want to follow me on Twitter, I talk a lot about this kind of stuff. I like to learn in public. I think it's like a really good way to learn stuff. I do live stream occasionally where like there was no real code demo here, but I do that on live stream. I'm still kind of experimenting with like better, which platform I like. I've done Twitch, but I kind of deleted it, but I don't know. We'll see. I'm getting more into that though. And I tweet a lot about Wasm, other tech stuff. I like to tweet about Vim projects and open source stuff. So yeah, I guess we can shift it over to questions. And I see William's question here. Why do people use Wasm in native mobile apps? Is it possible at the minute? Do you need some sort of wrapper? Excellent question. Yes, you need a wrapper. Really, you need to compile things to Wasm to run on a native or mobile app. This particular piece is actually quite interesting. And back to the future prediction stuff. There's this idea that if you got like near native performance and interaction in something like a browser, then and like it was just as good or so good, close enough that you couldn't even tell the difference with like a mobile app. Why would you need things like the App Store, right? Why would you need the Google Play Store? And so there's definitely some excitement in that space. Right now, it's I would say that desktop apps and mobile apps, not browser-based Wasm. So there's like, you can use a Wasm runtime and have it execute just natively, right, on your machine. And then you can also interact with the GUI, like things like that. I don't know a lot about those projects. I know that they exist. One big one that you can check out is it's called eGUI, right? And eGUI, like Brian's talk actually that he gave last month, he talked about it. eGUI is kind of like, they had this idea like, let's make something that can be a Wasm-based desktop app, mobile app, and web app, and we'll figure out all the implementation details, right? Super cool project. But yes, yeah. So like to do that, you would have to figure out how to like, okay, so like if there's like something that's written in C and it does pixel manipulation, like how can you do that in WebAssembly, and will it have all of the interfaces that it needs that it would normally have in an operating system, which is a bigger problem, but it's definitely possible. Yeah. So cool. But yeah, so thanks again. And other questions, I guess I'll just open it up for questions. Yeah.
First, this was great. Thank you. I remember Stackblitz sharing their web containers and seeing
Sweet.
that like the node stuff could run in the browser without needing a connection and things like that. And that was really neat. I started looking at, they have a little bit on GitHub, but I think it's just discussions and not the code, like you said.
Yeah.
Yeah, that.
Yeah. Yeah. They, I think what blew me away is like, yeah, see, here's the stuff that they built from hand, like by themselves. They basically created an operating system in the browser, or that every part of the operating system that Node would need, they made it in Rust. And this guy actually don't tell anyone, but I've been trying to get Dominic, who is the lead developer on this project, to come speak at our Chicago meetup. and he has this thing where it's like this is, here we go. Alan Kay, who like was this developer who invented object-oriented programming, has this idea about browsers that like they should basically be they should be a operating system. They should be miniature operating systems that should just run. And then if that happened, computing would change forever, right? Like things about like how you run stuff, where you run it, it should all be available the same, or like your code should not have to do very much work to figure out why it's different. And that's kind of where WASI, the WebAssembly system interface, is going. Kind of like in principle. How it gets there will be kind of a bigger question. And actually, it just reminds me, because I did have a quote about that I think I skipped. I was kind of getting carried away. I think I skipped a quote about this. Yes, this guy. Yeah, Solomon Hykes. This guy is the creator of Docker. And he tweeted this in 2019. And he said, if Wasm and WASI had existed in 2008, we wouldn't have needed to create Docker. That's how important it is. WebAssembly on the server is the future of computing. A standardized system interface was the missing link. Let's hope WASI is up to the task. So this is obviously pretty big like assertion from like someone in this space. WASI is still getting there. Like it's still getting there. But if you could do like, let's say everything that you could do in a Docker container, but smaller and faster in a WebAssembly module, it's kind of like a no-brainer. Like which one would you use? But like I said, a lot of this stuff is being worked on actively. So cool. Other questions from anybody?
Are you familiar with what Figma story is there?
Yeah, Figma.
That's one I use I use a lot.
Yeah. You guys, I feel like a lot of React devs use Figma. I should have brought that up. Yeah. This is a cool blog that goes over it. I'm a big Evan Wallace fan. Like he wrote, what's the transbundler? ESBuild, right? I think, or I think he wrote ESBuild. Anyway, ESBuild has a sweet WebAssembly. Like you can use ESBuild in the browser with WebAssembly. He like made it work as a compilation target, I think. But yeah, this is pretty sweet. I mean, I think I actually thought about adding this to talk about it. But basically, like the long story short is they took a C++ library that they use in Figma. Yeah. Okay. Cool. Yeah. And they C++ and C have this. I didn't go into the tooling here because it's kind of like a bigger topic, but the tool chain, the oldest one that's the most established, is mscripten. Okay, so if you are a C or C++ dev, or if you've done any of this and you want to compile stuff to WebAssembly, that's based on what the work that the LLVM folks have done, which is low-level virtual machine, right? There's a bunch of tools that are about optimizing these types of things. This is where you'd start, okay? And that Figma, this article talks about how they took this, they took the C++ library, compiled it to WebAssembly, and it gave them a performance boost, in their browser-based technologies. I've never actually really used Figma, so like I haven't done a ton in like the design space, but I do have a friend. I've got some friends who really like it, and then I've got some friends who aren't as fond of it. So it's kind of like I didn't really know where people stand on it, but it is cool, and they are definitely using it. Yeah.
If anyone hasn't used Figma, it's basically like a design tool. And when you're using it, you don't know, you don't know what technology is written in. You're sitting there scratching your head, like, are they using Canvas? Are they using like WebGL? Like what's happening? But it just works. Like it's pretty performant, and it like you think it's web technologies, and it turns out it's not under the hood.
It's wild. It's totally wild. I was gonna say too, like the things like that, how you said like you don't know how it works. I remember like my first experience with Google Docs being that way years ago. Like when they first came up with that, I was kind of like, what? And I think that like an analogy that you could make is that like WebAssembly, because Google Docs leverages like Canvas like a lot, I think. And you could also sort of, if you like zoom out, like WebAssembly might enable more Google Docs like things to happen on the web even more seamlessly. Somebody just ported, I'm not going to demo this, but somebody just ported, I think it was LibreOffice. Yeah, you can try this on your own, but it's 300 megabytes. Okay, so like you would like load it and then you have to like go get some coffee and come back, but it does work. And it's more of a proof of concept. But like things like that, like if you can port what is almost the original LibreOffice to Wasm, like that opens the door for things that are pretty interesting. But again, right now, this stuff just, it doesn't work by itself. Like you have to go in and figure out if that C++ code is going to like error out when it tries to make a system call that isn't available to it if you compile it to Wasm, right? Which for these like Stacklets guys was like a very, very tedious process from what I heard to make that Node.js runtime. Still cool once you got it done, you know? Cool. Yeah, other questions? I think, yeah, are these up here? Yeah, cool. All right, yeah, I hosted these. So here are the slides. Hit up the slides if you want. I'll just leave these hosted for quite a while. I don't need to bring them down. But yeah, yeah. So like I said, thanks again. And if you have any other questions, feel free to hit me up on Twitter or through Will or whatever. And yeah, Will and everyone else, thanks so much for having me. So.